Hi, Simon. It's great that we met here at the JCON conference. I was talking to you at the mentorship session that you have about modernizing applications, and there were a few topics that were quite interesting. I also work a lot on modernization projects, and maybe one thing that is still quite common that uh, companies try to move from monoliths to microservice architectures, and but there's also already also some like counter trend that says, okay, microservices are too complicated, and maybe it's good to go back to the monolith way. And we also talked about the Conway's law, which is, I think, a very great thing to look at things, because if you have some organizational structure, you have some teams, usually the structure of the teams will be somehow reflected in the design of the system that you produce, that they produce. So I think still the dividing the system into some parts that are autonomous to as much as possible actually is beneficial, because then the when there's one system that doesn't have to be maintained by multiple teams, but by just one team, then that one team can move faster, the deployments can be more frequent, and that's usually good for the business. So what's maybe your experience? Would you recommend using splitting applications into smaller parts so that we can align with the Conway's law, or are there any other tricks that we could use?
No, I think you perfectly did a conclusion about what also my thoughts are, because it's very important to see that, first of all, Conway's law is perfect, as you said, because it really aligns with communication structure internally in the company. In my opinion, what's also important is that the team must be big enough. So in big enough, I mean, if you have a large team, you should split it, because otherwise you will have a lot of communication between the various parts in the application or in the team, and this will slow down everything. You know, communication slows down. Not only if you communicate over the network, for example, so if you do distributed systems, but also internally in teams.
Okay.
So it would be very beneficial if you can have, like, okay, we say we create a module. I talk a lot about self-contained systems as an architecture style, where also the UI and the business logic and the database is included in one, I would say, subsystem, so to say, and then one team should be responsible for that. And as you said, what's very important is that the team can move forward without waiting for others or waiting for the whole company to release something, because the more frequent you release, the less bugs you can introduce in the release. But what I see, and that's in my opinion anti-pattern, is to use microservices and to split it very fine-grained.
So you said that the granularity of the services shouldn't be too fine, too small. Yeah, I agree with that, because I also have the experience that at some project they decided to okay, we are going with microservices. It will give us scalability, and that will be great. And they split something into microservices, but they didn't really define the business boundaries of those microservices, which microservice has what responsibility. And at the same time, all the microservices were developed by the same team, one team. They even shared the same database tables, on the back end. So to me, it didn't make sense because it was just more complex. With every feature, you had to think, okay, which microservice should I put it in? How, if I need to change the database schema, how will it affect the other microservices? And it was still one team, so it didn't even align with the Conway's law. So this is not the right way to do it, right?
Exactly, because there you just introduce distributed communication. Mm-hmm. You have latency, you have all the problems that you get if you do distributed systems, mm-hmm. and that's doesn't make sense. And as I mentioned, I had a customer that did microservices in the very early days of microservices, and I once asked them, how many microservices do you have? And then they said 20. And I said, okay, you have a huge team. And then said, no, we have just 5 people, but we have 20 microservices. Okay. But we now have problems. For example, we have to update Spring Boot, and we have to do that 20 times. And as you said, they were relying, they were splitting the database behind, but they had so many API calls in the system that the performance wasn't good at the end. Yeah.
Okay. But as we said, if it's reasonable, like you have a team that has some microservice, and it helps the team to have less dependencies on other teams, because there is a clean separation of the domain that they work on, and also on the technical level that you have like well-documented APIs that you use to integrate with the other services, then it should work.
Yeah, absolutely.
I
think that's also the idea behind microservices, that you first of all can split a huge project or a huge application into smaller parts that are better manageable. You then have smaller teams that do not need a lot of communication. And finally, if you really need that, you could go ahead and scale certain microservices in a different way, or scale up, scale out, whatever you need to fulfill the requirements. Because very often, like, one advantage of microservices, people say, is you are technology-wise neutral. But the problem is, usually you do that in, for example, Java department, and anyway everybody is using the same language, probably also the same tools, and that's not really the goal, in my opinion. Maybe it could be if you have some specialized parts of the system, for example, search engine is a better data store than a relational database, then you can split it out. For example, the product search microservices or something like that. That could be beneficial. But other than that, I think the number one reason to split an application into smaller parts is if the team becomes too big. That's very important. So that really speeds up and is more efficient.
Yeah, and also an interesting idea that we talked about yesterday was that oftentimes actually the technology is not the most important, or the technical stack, because the technology changes very quickly, but the developers, what's really important about them is that they learn the business domain, and that doesn't change so much. And that's what we should put more focus on, that really the systems are domain driven. So for example, even if we design those APIs, which is like my focus, we should strive to use, for example, naming that name the attributes and the objects so that it makes sense in the business domain. So we shouldn't make up some technical names. We should try to copy the structure that's used by the business. So if we know that something is called, I don't know, customer, and we can have multiple customers per, I don't know, segment, or making up, then we should name it that way. And also the schemas that we use should reflect the reality of the business. And so for example, if we have like, we don't know exactly the attributes that some objects can have. The first thing that programmer instinct will give you is, okay, I will just put some generic key value structure there, and then it can contain anything, and it will work, and it will not break for anything that the business guys will tell me. But in my opinion, it's not the right approach, because seemingly this API is generic and it will work for everything, but in reality it will break the other side that's connected to it wherever you add some new key and key into that key value structure, because the other service wouldn't recognize that. So in my opinion, the better approach is maybe put there what I know that makes sense in the business, even though it can happen that in the future something changes that I will need, so I will have breaking changes in the schema, but it will be more fair, it will be more visible, and it will give some feedback to the business that, okay, probably the analysis and specification of requirements wasn't sufficient, and that's why we developed it with only those information, that information that we had. So in the future, maybe we should be more detailed. So my point is, the business look should be the most important, so that we build good systems also technically.
Yeah, absolutely. So in my opinion, if you open a project or you clone the project from a Git repo and you look at it, you should immediately see the domain. Mm-hmm. You should see the domain structure, the domain names, and because the technical implementation is just irrelevant. Like that was kind of a mistake that people often did when using layered architecture. That doesn't mean that layered architecture is not a good idea, but the naming is not good. So if they split it like UI, then business and integration, for example, and persistence, that simply doesn't make sense, because that applies probably to every application in the world. Yeah. So you should really name things, as you said, and especially in Switzerland we have an issue with that, because we have 4 languages. And the business, for example, in the wholesale domain when I'm working, we have specific terms that only exist in the German or French language, and in the German language from Switzerland, not in the German language from Germany. So we have certain, and in the past, in that they try to translate that to English, and you should be very, very careful if translating domain terms from one language to another, because maybe the term doesn't exist in English, or you end up with
one term can have
multiple meanings.
Okay.
Exactly, and that's very, very, very difficult.
Yeah, but also if you were just in one language, I saw such situations like that. In some context, something can have different meaning. Like even a very simple thing, coverage. In our case, I'm working for an insurance project, and so insurance coverage means if you get money for some damage or not. But at the same time, we have a test coverage in software, so we want to cover something by tests, and we already have a name clash there. And we, in my opinion, in such cases, it's better to maybe come up with maybe a little bit artificial name, but at least so it's unique and everybody understands the same by it, so that it's not confusing.
Yeah, exactly. I even had that situation that I was talking to the business people, and I had to look at the UI where I found the German translation on it, and then I had to go to the code of the UI and check how it is translated in English, that I can find out on the database which attribute of the table, for example, they mean. That's very, very difficult. Yeah. But as you said, it's very important. We build software for business and not for technology use, right? So that's always an advice from me for junior developers. Choose maybe your employer by business domain, something that you're interested in. For example, if you like trains, you should have a look at jobs at railways, or if you're interested in insurance ID, then you go to an insurance company, and not about technology, because technology becomes old. And you still have this technology in 3 or 4 years, and maybe this becomes boring. And if you don't like the business domain you're working in, maybe this will be even more boring for you to work. And if you work in an environment and have a business domain that you are interested in, you learn a lot, because the most important knowledge that software developers have in companies is the business knowledge, not the technical knowledge, because technical knowledge you can learn. You can come to conference like JCON and learn about AI, how you do Java with AI, for example, but you will not find a talk about speaking about retail, or a talk speaking about insurance domains, for example. So that means that you really should work in something.
We should
that
create conferences.
The business conferences, talking about that. I mean, there are conferences, but not software related. You know, there are conferences for.
Yeah, because I think having conferences that are aimed at the technology just reinforces the situation that people come to increase their competence, and they only increase their knowledge of the new frameworks and new language features, but they don't really realize the value of the domain knowledge that they have.
Exactly. So, and if you know the domain very well, by the way, and if you go to a talk about AI, for example, you can imagine what you could do with AI, because you know the domain, and you maybe even know there are some parts where you could benefit from AI or from any other technology out there, and you can integrate that, or you can propose to integrate that, because you learned about that, and you know exactly where it could fit in your domain that you're working.
Okay, and one more thing, you already mentioned self-contained systems. I don't usually use this term, but to me it's like a combination of microservices and micro front ends in one bucket. Is that correct, or is there something wrong in my understanding?
It's only wrong on the client side, because micro front ends means that you integrate multiple parts of these micro front ends in one UI application. Like you have, like we had portals. You remember portals? Like portlets 20 years ago.
Yeah,
that was an idea of kind of micro front end back in the days with Java.
Yeah.
This didn't took off, but self-contained systems have the idea that you really have a separate UI. So you don't integrate at the UI level, you integrate at the UI level via links. So you link from one self-contained system to another, so they are very strictly separate. But for sure you could also use like something like micro front ends. For example, you have some parts of your UI that you want to integrate, small piece inside it as part of a micro front end, then you could do that as well. In my opinion, self-contained system is a term that was introduced by InnoQ, that's a German IT consultant company, and in earlier days we just called that subsystem. So we had a big system, we split it into subsystem or application parts or something like that. So that's not really new, that's something that we did in the past. If the application became too big, we started to split it. The problem that we had back then is that deploying multiple services was way more complicated. Now with all the cloud stuff like Kubernetes or something, where it's very easy to spin up an application or a microservice or a self-contained system, this became more doable. So that's the only change. But I think self-contained system is quite an old concept.
Okay, but is it good from the user experience point of view? Because the user experience professionals would say, but it should be somehow unified. I shouldn't. It should behave like one system and not like I'm jumping between like when I'm developing. I have IntelliJ IDEA, then I switched to a browser, then I switched to Postman, and then I switched to command line, and it's not very like I can work with it, but it's not. It's nicer if it's everything in one window and behaving the same way.
There you have to consider two things. First of all, you have to have a design system. So that's something that you have to have anyway if you're a company and want to have your applications look like the same everywhere. And you have to create like common components, common look and feel, common theming. I'm usually use One-In, and there's very simple to do that because this will be just maybe not Gradle dependencies that you integrate in your project, and then you have all the components and all the styling for each application. On the other hand, you have to consider that self-contained systems are not that small. So thinking about splitting the business domain with Conway's law, then you may have the situation where none of the employees even work with two self-contained systems. So they usually stay in the self-contained system. Because what we do, for example, let's take the simple e-commerce example. We have an order management system, we have a product catalog. So the people that are working on the product catalog, they work there and create new products, define the prices, and what we do, we replicate the data to the order management system. Because we just take the information from the products that we really need to be able to order that product. So we don't need the information about who's the supplier of that product. We don't need the information what the company pays for the supplier to get the product, for example. We don't need a lot of information that the product manager is usually managing in product self-contained system. And so we have a small set of data that we replicate, for example, and replicating can be done in very different ways. You could do message, you could have a message store with message sourcing, or you could do message streaming, or even you could just replicate with a tool that replicates data. So you define a view on one side, and then you replicate that view as a table on the other side. So you will be completely independent between these self-contained systems. So the situation that really someone wants to go from one self-contained system to another, that's in our case now in the product that I'm currently doing very uncommon. So there's more like this.
In reality, they always do it to some degree because they use Outlook and they use, I don't know, the company's time tracking system or something like that.
I'm just talking about that. But it's not a self-contained system in that meaning, but if you use Amazon to order products, for example, you have different applications during your checkout process. In early days, you could see that because every part or every step looked different. So they didn't even have the same style from one step to another. But they really move from where you search for the books, for example, to where you add it to the basket, and then the checkout process is another application. In fact. And you don't notice that really. And I mean, in early days, linking that's just the way the internet works, right? So that's not an issue. So that's more an issue about people thinking about that because they are used to I mean, most of the microservice projects that I see have a monolithic front end. So they gain nothing. So they just have the back end independently deployable, but the front end is a monolith.
Or it can be modularized somehow. It's currently the trend also for the back end, but not always. But you're right that I remember in the early 2000s also working on a front end where we used links and page refresh, and at that time I realized also that actually the URL is also like an API because it can have some parameters, and it's also important to watch it so that it's like well documented and so that it doesn't break. So the principle is the same as today. We have maybe also these micro front ends or some other stuff, but
but it's always about defining the boundaries.
I mean, in the end, a URL is RESTful, you know, so you get something back. Today we always talk about JSON, getting back from a REST API, but you could get HTML back.
Yeah.
So it doesn't matter because it's a resource.
Yeah.
And then linking inside, I mean, if you're using HTOS, then you also have links integrated in your JSON that you get back from the server, for example. And you could do the same because, as you said, that's very important, because if I really want to, for example, go from an order with an order item directly to the product in the product management, the API must be stable. Otherwise, it will not find the page that should be displayed. So that's very important to manage that. And we currently do not need that, but when we go further with modernization, we will create kind of a link database. So you could ask, okay, I want to access, for example, the product service or the product microservice subsystem, and I want to, what kind of parameters do I have to pass, and what is the URL? Because it depends on the stage where you are. Maybe the URL is a different one.
Okay. Yeah. So thank you very much for answering my questions and providing some interesting insights to all who watch this, and continue the great work.
Yeah, thanks a lot for having me.
Yeah.